All right, to understand how to solve rational equations, you have to understand, oh my goodness, we have to do LCDs. What's an LCD? Least common denominator. Of course, it's not going to be just with regular numbers, it's going to be with polynomials, okay? So before I show you with polynomials, let me take just a second to show you with regular numbers. If I had something like 2/3 plus 1/5. How would I find, how do you find that though? You're doing it in your head, but how do you actually do it? You can, but you want the smallest one. So really, least common denominator is another word for least common what? It starts with an M? Multiple, right? So the multiples of 3 would be 3, 6, 9, 12, 15. The multiples of 5 would be 5, 10, 15. So the smallest one that they have in common is 15, right? And so what I do is I would look and I would say, okay, so what does this need in order to become 15? Times 5. And if I do it to the bottom, I have to also do it to the top. And then same thing over here. This needs a 3. So this would become 10 over 15 plus 3 over 15, right?
Yeah.
Okay. Do I? So what if I change this from nice whole numbers to something like all right, so back to this one, if my screen will go with me. Let's say I have x plus 1 over x minus 3 plus 2x over x minus 2. Okay? We did. So now I need to look at, okay, I need an LCD here. So you're looking at, you really want to look at things as a whole, okay, or in multiplied terms, because that's what's going to help you. So here, the LCD, I have to employ the technique that Taiji was saying just a minute ago, where we just, was that you or Jada? Might have been you, Jada. We just multiply the two together. When you said multiply 3 times 5, somebody said it, okay? And so here, what I'd want to do is multiply x minus 3 and x minus 2. So in order to force an LCD, well, no, I don't even want to foil it. I want to look at what it's missing. What's the first one missing? What do I have to give it to make it look like the LCD? X minus 2. What? Do what? I'm sorry. Okay, well, Cameron said it. I'm sorry. Because I'm just teaching. I know it came from this area. I don't know. All right. Now look at the next fraction. What's it missing? To make the bottom look like the LCD, an x minus 3. So now the denominators look the same, right? I'm not going to worry about adding them just yet because that's not, we're going to do something else with them in just a second. I just really want you to focus right now on the concept of LCD and how we force LCDs. What if sorry, let's make it a little more difficult. For right now I just want you to focus on LCD and then we're going to do a little bit more with it. Jerome. What if I needed the LCD for these two? Now, let me give you a hint. You always let your first step be to factor anything before you start. Can I factor anything there? I sure can. Which one factors? The first one, right? Since the leading coefficient is 1, girls, since the leading coefficient is 1, I can just do the factors of 3 that add to -4, right? I don't have to go through the whole grouping process. So what multiplies to 3 but adds to -4? 3 and 1, both of them negative, right? X minus 3, x minus 1. Now look at these two fractions. What's the LCD? Exactly. The first one is good. Do we agree? Do y'all remember doing this in Algebra 2?
Yes.
Okay, honors got there. I don't think CP got there. So if you took CP Algebra 2, you didn't get there. If you took honors Algebra 2, you did. All right. So this one is missing the x minus 3, right? So that's what it would need, top and bottom. All right, so I show you all this so that I can show you how to solve equations that have these fractions in them. And I think I'll give you some steps as we do them. Yep. Before I show you the hard stuff, and that is just in general solving equations with fractions in them, okay? If I had something like 2x over 3 plus 5 over 3 equals 7 over 3. See how all the denominators are the same? Okay. When you get all the denominators the same, this is going to be the key for solving equations, rational equations, okay? When the denominators are the same, what you can do is you can drop them and use the numerators to solve. Okay, but they have to be exactly the same. Come on, pen. Okay, so what we're going to do, and I hope you're starting to see where we're going with this whole LCD thing. If we can make everybody have the same denominator, then we can just get rid of the denominators and use the numerators to solve the actual equation. So here we would have 2x plus 5 equals 7. If all the denominators are the same, then we must be able, the numerators have to be equal as well. Okay? And then we would go through and solve. So let me show you with some rational equations here how we're going to do it. All right, let's say I have, we'll start easy. I'm going to say how to solve rational equations. All right, so the first thing we want to do, let's say I have 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Tell me what you think you do first. Okay? So whenever we're doing that, what do we need to do first? Exactly. We need, and the process of finding that LCD, what we're going to do is we're going to factor anything that we can to start with. Do you see anything in this equation that can be factored? Yeah. I think we just did this one, didn't we? Didn't we just do that factor? Okay. So we have 2x over x minus 1 plus 1 over x minus 3 equals 2 over x minus 3 x minus 1. Did I confuse anybody? All I do is factor. All right. So now, Cameron, yes, we're going to find the LCD. But as we look, we're looking for every piece in the equation has to have the exact same denominator. So what in this case would be the LCD? X minus 3. Is that it? X minus 1, right? Okay. Start multiplying them together, but just don't repeat any as you go. Yeah. This one, I factored x squared minus 4x plus 3. What multiplies to 3 but adds to negative 4? All right, so I'm going to say force LCDs. In other words, make everybody have the same denominator. So what's the very first fraction missing? X minus 3. Top and bottom, right? What's the second fraction missing? X minus 1. Top and bottom. How about the last fraction? It's good, right? Good to go there. Now comes the fun part. Drop the LCDs and solve using the numerators. I'm going to give you a second to catch up with me before I actually do it. Pause. All right. If I drop the numerators off, I end up with 2x times x minus 3. Here you get more practice with your foiling and your distributing. Watch signs. If this was a minus, we would be distributing a negative 1 through to that x minus 1. And it equals 2. Okay? So now this is an equation you should be able to solve. I think it's going to be a quadratic, which means we're going to have to employ some techniques for solving that we're very familiar with. Possibly. Maybe it'll factor. I just dropped off the denominators and only used the numerators. So I had x minus 3 times 2x, 1 times x minus 1, and 2. I only took the tops of the fractions. All right, so I get 2x squared minus what? How do I solve a quadratic that looks like that? Combine like terms and make the equation equal what? 0. That's always my first option when I've got quadratic. So I'm going to move this 2 over, and I'm going to go ahead and combine these two. This becomes a quadratic solve now as opposed to anything harder. Can this be factored? Yes. What multiplies to, and I am going to have to group this one. Does everybody see why? There's a leading coefficient, right? All right, so tell me what multiplies to negative 6 but adds to what? Negative 5, negative 6, and 1. So I have 2x squared minus 6x plus 1x minus 3. We didn't have internet yesterday, so emails are rolling through now. All right, so what can you take out of the first two? 2x. What's left? What can you take out of the second two? What's left? What does it look like factored? The goal was to solve. So what are my solutions? I should have two. -1/2 and +3 because I got 2x plus 1 equals 0 and x minus 3 equals 0. There's not, the only new part here is forming the LCDs. Let me show you one more that may confuse you. It's actually easier than this one. What do I do first? My first step is to always try what? To factor. Can anything here be factored? No. So now I need an LCD. I hear 1, it's 1x. Okay? So look, this is really, anytime you have a whole number, it's really over 1, right? So here my LCD is x. I don't have any choice but to make them x. So my first fraction and my last fraction are going to need x, right? To make them have the same denominator. So I'll do an x and an x, an x and an x. So what does my equation look like? X squared. What do I have? Starts with a Q. We've done a million of them. I have a quadratic equation, which means I go through my steps. Can it be factored? I'm going to go ahead and make it equal 0. Minus 4x. Put it in standard form. Can it be factored? Can I complete the square? Should I use quadratic formula? What in the world should I do? I can factor it. Easy because there's no leading coefficient here. So what multiplies to 3? But that's the same one again. I'm getting them out of the book. I'm using ones that do work out nice. So, goodness. The first one I did make up. So my two solutions are 3 and 1. Does that make sense? Does it make dollars? Just real quick, just to make sure I won't work this one all the way through. Oh, sorry. I hit base going. I just want to make sure you can find the hardest part is finding the LCD, and I just want to make sure you can do that. So I want to show you one that's a little bit harder for the LCD and make sure. All right, so take all your bottoms and put them together, but don't include any repeats. So let me show you. This one is one that'll be a good example. X minus 3 over x plus 3 over x plus 2 plus 6 over x squared plus 2x. Can anything here be factored? How does that factor? Close. Can take out, it's x plus 2. You can take an x out, and it leaves you with x times x plus 2. So now, what I tell students that struggle with writing LCDs is, start with your first one and write it, x. Go to your next one, okay? And we're looking at factors, whole chunks multiplied together, okay? This has got an x plus 2. Do I already have an x plus 2 in the LCD? In the LCD? No, so I need to add it. Now I come to the next fraction. It's got two parts, an x and an x plus 2. Do I have an x already? Yep, so I don't need that again. Do I have an x plus 2? Okay, so I don't need to add anything else to the LCD. That is the LCD. And then you give everybody what they need to make a match. So, right, this would need an x plus 2. This would need what? An x. And then you can drop the bottoms off and solve. Does that make sense to everybody? You need me to finish solving this one? Okay. Yep. Yeah, try it, and then we'll come back and do it. Yes, yes. So the first one's going to be a FOIL problem. plus, that's multiplied. Whenever you add a piece from the LCD, you always multiply it. So that's 3x, and then we have plus 6 equals 0. Stop now? Okay. How about if I work it but don't say anything and you can look up and check? Maybe you did. Maybe I did it in...
Because I got the 3x. I don't have the 3x. I got x squared minus x. Where did the 3x? That's what I've been thinking.
It is my... I foiled it.
Yeah.
Minus 3x plus 2x minus 6.
I got x squared.
That's...
There's a 3x.
It's minus 6. So now I factor x times x plus 2. So x could be 0, or x plus 2 could be 0. So my two solutions are -2 and 0.